Welcome back, ladies and gentlemen. So today I'm going to be showing you guys parallel lines and transversals practice quiz. Okay, so we're going to walk through this. And of course, as we're going through it, if you ever have any questions, feel free to raise your hand and we'll go from there. Okay, so to start off with, we have a picture over here to the side. Okay, and we've got a lot going on here. But let's take a look at number 1, part A. They're telling us that FB is perpendicular to AD. So that means that this is a right angle in here and all the way around. Okay. 7 is 42 degrees, then 3, directly across from it, vertical angles must also be 42 degrees. Alright, awesome. The measure of angle AHB, well, AHB, if we know it's a right angle, we know that must be 90 degrees. Okay, boom. Please make sure also as you're going through all of this that you're including degrees for it. 6 and 5. Okay, so the measure of angle 6 is 63 degrees, which is right here. And then that means angle 5. Well, think about this. It forms a right angle. So for part C, I want to take a look and go 90 minus 63, which gives me 27 degrees. Wonderful. The measure of angle 3 equals 51, and the measure of angle 1 equals, well, be careful here. If this is 51, that means that angle 7 is 51. Okay, so directly across from it. 1 and 7 have to have 90. So I can do 90 minus 51, which gives me 39 degrees. Okay, so that means that angle 1 here is 39 degrees. And just to point out also, all of these are separate from each other. So like, this one's different than that one. You get the idea. The measure of angle 3 plus the measure of angle 4, okay, well, it forms a corner. Every corner has to be 90 degrees. Awesome. Okay. Down here we've got a picture of a box, and it says use the diagram at the right to answer the following questions. Name a line parallel to XW. So it just wants one line. Well, there's a few lines I could name. Here's XW. I could name line TS. Make sure that you're putting arrows over top of it. You only need one, but you could also have said QR or UV. And again, you can flip them around as well if you'd like. By all means, feel free to. Name 2 lines perpendicular to QR. Well, that means it's a line that hits it at 90 degrees. Well, it actually kind of gives you the answer right here. You've got QU, and you've also got RV, which could possibly work. Okay, so I know it just says name 2 lines, but just to give you guys the other ones as well, you could have also said TQ, and you could have said SR. I'm hoping you guys realize that whenever you're naming lines perpendicular to something, you see how it says QR here? Every one of these either has a Q or an R in it. So perpendicular lines have to intersect. Name a line skew to WV. Well, here's WV, so you could have said QR going across the top. We could have said TS going across the top. Okay. And instead of that, we could have also said TX going straight up and down. Oh, apologize for that. Sorry about that. Sneeze. You could have said TX, or you could have said QU. Both would have worked as well. Okay. Now, scrolling down a little bit. Here's a picture. Okay, we've got 2 lines cut by a transversal. The little arrows here mean they're parallel. So we're going to label what they give us. 98.5 for angle 1. Okay. Directly across from it is also 98.5. Okay. Ladies and gentlemen, what does a straight line equal? Well, a straight line equals 180 degrees. So if I do 180 minus 98.5, okay, I can go ahead and take a calculator. We're looking at 180 minus 98.5, 81.5. Right? So that means that these other ones are going to be 81.5 degrees, 81.5 degrees. Now, I am basically picking this up, and I am bringing this down and dropping it on the other thing. All right, so I can bring this stuff straight down. So the 98.5 is in the top left-hand corner, which means 98.5 stays in the top left-hand corner there again. And basically everything just falls on top of it. Okay, So if you put the hard work up front, now everything you just kind of match stuff up. Angle 4, okay, is just going to be, okay, so 4 is 81.5 degrees. Angle 2 is again 81.5 degrees. Angle 3 is 81.5 degrees. And then angle 5 is going to be our 98.5. Okay, cool. Everything stems back to that 180 idea too. So you'll see that again and again. All right. Down here we are naming some special angles. So we're using a diagram off to the right. 1 and 8. 1 is on the outside and they're going across the transversal. Therefore they are alternate exterior. Okay, very nice. 2 and 6. So 2 and 6. 2 is in the top right-hand corner. 6 is in the top right-hand corner. Corners are corresponding angles. Very good. 5 and 4. Same idea as 1 and 8, except instead of going across on the outside, they're going across on the inside. So that's going to be alternate interior. Nice. 3 and 5. Notice that here we're staying on the same side of the transversal, so that's going to be consecutive interior. Okay. 1 and 5, top left-hand corner, top left-hand corner. Corners are corresponding. And finally, 2 and 3. This is kind of a little bit of a curveball for you, but it starts with a V. When they're directly across from each other, those are vertical angles, which are always nice because they're always going to be congruent. All right, so we're going to flip to our back side. Okay, so here we've got a picture drawn. This little box stands for 90 degrees. So I have these two adjacent angles next to each other. Please don't just set x minus 5 equal at 90, because clearly that's not a 90 degree angle. What I can do is say x minus 5 plus 3x minus 7 equals 90. So I can add them together. Combine like terms. X, 3x gives me 4x. Negative 5 minus 7, negative 12. Boom. Okay. I can add 12 over. 102. And then I can divide by 4. I believe it's going to be 25. Let me just double check here. Okay, so we've got 102 divided by 4, 25.5. Alright, very good. Hopefully you notice that over here this is much the same. Alright, I've got two small angles. Here's a right angle being formed. So I'm going to add these two again together. X plus 3x equals 90. X and 3x gives me 4x. Okay, so if I take a look and do 90 divided by 4, 22.5. Don't stress if you get a decimal for an answer. It's totally fine to do so. All right. Good, good, good. All right. This is very much like the notes that we did the other day. So for this one, you're going to identify what kind of angles they are and then figure out if they equal each other after 180. So 6 and 3. 6 and 3 are on the inside across, so that's alternate interior. And we know that alternate interior are equal. So we can say 2x plus 30 equals 70. All right, solving this, I can subtract 30 from both sides. 2x equals 40. Divide by 2, x equals 20. Okay, awesome. So now this next part is completely separate. Notice that 6 has changed from 70 degrees to 80 degrees, so it's a whole separate problem. 6 and 2, top right-hand corner, top right-hand corner. Okay, corners are corresponding. So again, they're equal. So I can say 5x minus 10 equals 80. I can add 10 over. 5x equals 90. Divide by 5. 18. Good. Number 3. 3 and 5. Okay, this is the tricky one. 3 and 5 is consecutive interior. Okay. They're on the same side. Okay? This is the one where I have to add up to 180 there, supplementary angles. So we are doing 3x plus 30 plus 105 equals 180 degrees. Alright, combine like terms, 3x plus 135 equals 180. Subtract the 135 over, 3x equals 45. Divide by 3, x is 15. This is again the weird one, okay? When it's consecutive interior, you have to add to 180. Everything else pretty much you make equal. 1 and 8, well, we use everything except for alternate exterior. So I'm going to make them equal. 3x minus 11 equals 70. I can add 11 over. So 3x equals 81. X equals 27. Boom. Okay. Sorry, I went a little fast in that last one. Just again, a reminder, you add 11 to both sides. That's how I got 81. Divide by 3. If you need to, you can take a calculator. 81 divided by 3. You got it. These are just extensions on the last one. So these are alternate interior. Alternate interior you make equal. Okay. So again, use your homeworks if you can. So I can say 5x minus 15 equals 80. I can add 15 over. 5x equals 95. Divide both sides by 5. 19. Alright. But notice the difference from here to here. Here I'm jumping across that transversal, but here I'm staying on the same side. When that happens, that's your special one. That's consecutive. They add to 180. So I'm doing 4x minus 9 plus 75 equals 180. If I do 75 minus 9, I get 66. Oops, sorry. Plus 66 equals 180. If I can subtract that over, 4x equals 114. Okay. Let's double check real quick. 75 minus 9. Good. 66. 180 minus 66. Good. And then divide that by 4. 28.5. Okay. Last and final one. I am taking these points, right, and I am plugging this into my distance formula. Every point is an x and a y, so x1, y1, x2, y2. So I'm putting things right in here. Be careful with the signs. So I've got x2 minus x1. Notice how I'm putting two parentheses around it. 7 minus -5 squared plus y2 is 7. 7 minus 2 squared. Cool. Now inside here I've got 7 minus -5 becomes 7 plus 5, which is 12. Here I've got 5. So I've got 144 plus 25. Okay, and then I can get square root of 169. Square root of 169, if I put that in my calculator, I get 13 as an answer. Okay? So, good stuff.
Yo!
What's up, Mr. Brooks? Alright, buddy. Sorry, that was Mr. Brooks stopping in, who's my absolute favorite person in the world. He's my hero. If you see him, please give him a high five from me. But if you have any questions, please feel free to ask me, and I will happily help you guys out. As always, keep up the good work and good luck. We're all counting on you.